Okay, hi, welcome back. We're gonna do question 5, which was the next one on the sheet. It said write down the formula for acceleration. So formula for acceleration is the final velocity minus the initial velocity over the time taken for that velocity to change. So we just wrote that in the previous question, but yeah, in words it would be acceleration equals change in velocity divided by time taken. Okay, and then in order to find the change in velocity, you do always take you subtract the initial from the final, right? So if I told you that I'm measuring the distance from here and you're 5 meters away, and then later on you were way over here, and that was 15 meters away, and I asked you to find the change in distance away from where I am, which is here. Then you wouldn't do 5 minus 15, right? That would give you a negative number. You would do the final distance that you're away minus the initial distance, and then you would get your 10 meters, which is the difference in distance away from me between the time later and the time before. So here it's the same. You take the final velocity and you subtract from it the initial velocity. So I hope that makes sense. And so that's our definition for acceleration. It can be negative or it can be positive. So negative would mean that the initial velocity is bigger than the final velocity, and if the initial one is bigger than the final, it means first you have a large acceleration and then you have a large velocity and then you have a small velocity. That means that you're slowing down. So if you're slowing down, this number will be bigger than this one, and therefore if you subtract a bigger number from what you have at the beginning, you will have an acceleration here that is negative, since this guy here, time, is always going to be positive. Okay, so you can have an acceleration that's bigger than 0 or positive, which means speeding up, or you can have an acceleration that's negative, and this means slowing down. You can also call this deceleration. Okay, and then after saying to write down the formula for acceleration, it says what's the acceleration of a soggy pea? I don't know what a soggy pea is, but it is flicked from rest to a speed of 14 meters per second in 0.4 seconds. So from rest, it says it flicked from rest. This is a really important word. We need to know what it means. To a speed of 14 meters per second in a time of 0.4 seconds. So that's the information they give us, and the first thing that I would recommend you always do with these questions is that you translate the words that you read, and you write down the letters and the variables that you actually have, so then you know you are less likely to make mistakes and use the numbers where they in places where you shouldn't be using them, or you use the wrong numbers for the wrong ideas. So here rest means 0 speed. Okay, whenever you see this word here, rest, that means 0 speed. So what they're telling us is that the initial velocity, the velocity it starts with, is equal to 0. Here they tell us that the final velocity is equal to 14 meters per second. So the final velocity is equal to 14 meters per second, and the time that it takes to go from one to the other is 0.4 seconds. So using our formula here, final velocity minus initial over time, we can calculate the acceleration really easily by saying final velocity is 14 minus the initial velocity, which is 0, divided by the time taken, which is 0.4. So I grab my calculator and I do this on there, then I get 14 divided by 0.4. I get 35 meters per second. What was the unit of acceleration? Acceleration has units of meters per second per second. So meters per second, which means meters per second times seconds, and that's meters per second squared. So we write it like this: 35 meters per second squared. And there we have our acceleration, which is what we were looking for in part A. And then we just check, we look at the answer and we say, okay, so it's a positive acceleration we just calculated, so this means it should be speeding up. Okay, this means speeding up. And then we should always check with the question to see if it makes sense. Okay, and the question says it goes from rest to 14, so then that means it's speeding up, and that makes sense. Okay, if this said that it's slowing down and we got a positive answer here, it means we got these two guys the other way around and we need to turn them around. Okay, it's really important that the formulas are consistent with what they give us in the questions. So that's for question 5, I believe. Yeah, so now we're gonna go on to question 6. We change back to white for no reason at all. And here it says, sketch a typical distance time graph and point out all the important parts of it. Excuse me. So we've got a sketch here, typical distance time graph. So let's see what a distance time graph looks like. That's time. This is the distance. And the typical distance time graph, and point out all the important parts of it. Let's see, a typical distance time graph could look like this. Straight line there. Assume it's a straight line anyway. Then a straight line there, and then maybe something like this, some kind of curve. Okay, and so let's point out the important parts of it. In a distance time graph, I always try to encourage you to ask yourself the same question so that you don't make mistakes. Some people find these okay and relatively straightforward, but for other people it takes a while to get used to them. So if you're still getting confused sometimes about these graphs, it might be a good idea to follow these tips when you start to think about them. The first thing to think about is like probably the most important. What does the y-axis represent? Super important. If you don't know that, then you're going to interpret this wrong, or if you just assume it's going to be velocity or whatever, you'll get it wrong. So what does it represent? In this case, the answer would be distance. Okay, then the second thing is, what does a rise in it represent? So here there is a rise in the distance as time goes on, and it means it represents whenever there's a rise in distance in a certain amount of time, it means you're traveling distance in time, so therefore there means speed. That's what it represents. There is some speed if there is an increase in distance and time. So in other words, it's not stationary, the thing is actually moving, so it must have some speed. The third one to consider is, what does a straight line mean? Okay, so what does a straight line mean? Straight line mean. In this case, a straight line, well, in all cases, just a second. Sorry, I just had an interruption. Okay, back on this. What were we saying? Straight line. Okay, so what does a straight line mean on this particular on any graph whatsoever? It always means a constant rate of change. Okay, so it always means a constant rate of change. Always. Okay, so this is not particular to distance and time graphs. It always means constant rate of change. The question is constant rate of change of what? Okay, that's what's important here, because depending on, and the answer is constant rate of change of whatever's on the y-axis. So here, if the y-axis is distance, then that's the constant rate of change of distance. Okay, and the constant rate of change of distance means rate of change of distance is how fast the distance is changing in time, and that's another word for speed. So constant rate of change of distance is so a straight line in a distance time graph means constant speed. Okay, so this is universal up here, this thing here. That is always true for any straight line in a graph, but this here is particular to only distance time graphs, right? Because if the constant rate of change referred to a velocity time graph, then an increase in velocity at a constant rate would be a constant acceleration. So here we have a distance time graph. It means constant rate of change of distance with time, and another word for that, a much easier word for it, is just a constant speed. Okay, so hopefully that hasn't confused you very much and that made sense. So here, now knowing all of this, then, well, this is, yeah, I'll just mention quickly, well, we haven't finished yet looking at what different things mean. So here, the fourth one, we could say, what does a horizontal line mean? Horizontal line means same distance. So here, a horizontal line. Once you've asked yourself these questions a couple of times for every question, then you'll find you don't have to do it anymore, because you'll really get the hang of it. But at the beginning, it's really useful to ask yourself these. So what does a horizontal line mean? No distance change, no change in distance. So if there's no change in distance, then the speed is 0, because it's just not moving, so speed is 0. So that's what a horizontal line means on the distance time graph. And finally, a curve. What does a curve mean? Well, a curve, let's see here, 5. What does a curve mean? On the distance time graph, it would mean a non-constant rate of change. Okay, so on any, and this is universal again, on any graph, it means non-constant rate of change. Okay, or non-uniform. So another word here is uniform rate of change. It's a very, very common word also to say it in. So here, a non-constant rate of change would mean there's an acceleration. Okay, if there is a non-constant rate of distance, then there is a changing speed. Non-constant rate of change in what? In whatever's in the y-axis. Since here we have y-axis, we have the distance. Then what's changing at a non-constant rate is the speed, is the distance. So therefore, the speed is changing. Right? If the constant rate of change is constant speed, then non-constant rate of change is non-constant speed. So the speed is changing, therefore we have an acceleration. So that's what the meaning of a curve is. So here we can look at these and say, okay, knowing what we know already from what we've just said, that means that here we have a straight line going up, so we have positive acceleration. Here we have a flat horizontal line, so we have 0 speed, or stationary. And here we have a curve going down, so we have negative acceleration. Okay, and I'm running out of time, so hopefully all of that makes sense, and I'll see you in the next video.